Aluminum armored cable should not be used with 277 volts applications, and there are several compelling reasons for this recommendation. Firstly, aluminum has significantly higher electrical resistance than copper. This increased resistance results in more heat generation when carrying current. Overheating reduces efficiency and poses a potential fire hazard. Secondly, aluminum armored cable exhibits higher impedance than copper. Higher impedance causes voltage drop issues, especially over longer distances. Significant voltage drops compromise equipment performance and introduce safety concerns. Aluminum and copper possess different electrochemical properties. When these dissimilar metals come into contact, they can create a galvanic cell. The formation of a galvanic cell leads to corrosion and ultimately causes failure of cable connections. Aluminum demonstrates lower arc resistance compared to copper. In the event of a fault or short circuit, aluminum armored cable may not withstand the high temperatures produced. Inadequate arc resistance can lead to dangerous arcing and fire hazards. Aluminum expands and contracts to a greater extent than copper when subjected to temperature variations. This difference in thermal expansion and contraction creates problems with cable fittings and connections. These problems can cause loose connections and compromise overall reliability. Using aluminum armored cable with 277 volts increases the risk of fire. The high resistance and impedance of aluminum armored cable can lead to overheating. Overheating drastically increases the risk of fire, especially during overload conditions. Loose connections resulting from thermal expansion can create potential shock hazards. These hazards are exacerbated in wet or humid environments. The voltage drop caused by aluminum armored cable can reduce the life expectancy of electrical equipment such as motors and transformers. It is strongly recommended to use copper armored cable or other approved cables for 277 volts applications. While aluminum armored cable might seem like a more economical option initially, the long-term safety, reliability, and efficiency benefits of using copper armored cable outweigh any potential cost savings. Consider the following factors to better understand the recommendation to avoid aluminum armored cable with 277 volts. Electrical resistance is the opposition to the flow of electric current in a conductor. Aluminum has a higher electrical resistance than copper. Therefore, for the same length and cross-sectional area, aluminum will impede current flow more than copper. This results in more energy being dissipated as heat within the aluminum conductor. Impedance is the total opposition a circuit presents to alternating current. It includes resistance, inductive reactance, and capacitive reactance. Aluminum exhibits higher impedance than copper, which means it impedes alternating current flow more effectively. This can lead to voltage drops along the cable length, especially in long runs. Electrochemical compatibility refers to the ability of two metals to coexist in an environment without corroding each other. Aluminum and copper are electrochemically incompatible. When they come into contact in the presence of an electrolyte such as moisture, they form a galvanic cell. The galvanic cell accelerates corrosion of the aluminum. Arc resistance is the ability of a material to withstand the effects of an electrical arc without failing. Aluminum has lower arc resistance than copper. In the event of a fault or short circuit, an electrical arc can quickly melt or degrade aluminum, leading to a fire. Thermal expansion is the tendency of matter to change in volume in response to changes in temperature. Aluminum expands and contracts more than copper for the same temperature change. This difference in thermal expansion can cause connections to loosen over time, leading to increased resistance and potential overheating. The increased risk of fire with aluminum armored cable arises from its higher resistance and lower arc resistance. Overheating due to high resistance can ignite nearby materials. The lower arc resistance makes aluminum more susceptible to failure in the event of a fault, increasing the likelihood of a fire. Shock hazards can result from loose connections due to thermal expansion. A loose connection can create a high resistance point, which can generate heat and potentially ignite nearby materials. If a person comes into contact with a loose connection, they could receive an electrical shock. Reduced equipment longevity occurs when voltage drop reduces the performance and lifespan of electrical equipment. The voltage drop caused by aluminum armored cable can reduce the efficiency and increase the wear and tear on motors, transformers, and other electrical devices. Using copper armored cable or other approved cables for 277 volts applications ensures safety, reliability, and efficiency. Copper has lower resistance, higher arc resistance, and better electrochemical compatibility with other metals used in electrical systems. This minimizes the risks of overheating, fire, shock, and equipment failure.